Next chapter, linear inequalities. Now in mathematics, a linear inequality is an inequality which involves a linear function. A linear inequality contains one of the symbols of inequality: less than, greater than, less or equal to, greater or equal to. It looks exactly like a linear equation with the inequality sign replacing the equality sign. Inequalities are as simple as they go. For example, take 2 and 5. 2 is less than 5, or you can say 5 is greater than 2. Those two statements can be represented using inequality signs: 2 less than 5 and 5 greater than 2. In inequalities, the sign always points to the smaller number. Now take an unknown value x. Suppose x is at least 7. It means the smallest x can be is 7, and so x is either 7 or more. We say that x is greater or equal to 7. Using inequalities, we write x greater or equal to 7. Now imagine y is at most 20. This means that the greatest y can get is 20, and so it's either 20 or less. We say that y is less or equal to 20, and we write y less or equal to 20. All this information can be represented on a number line. Consider x is greater than 5. We draw a number line, and then we circle 5. X includes all values greater than 5, and 5 is not included, and so we use this arrow to indicate that. If x is less than 4, we circle 4, and x lies anywhere on all numbers less than 4. Now consider x greater or equal to 5. This means that x includes all numbers from 5 and more. 5 is also part of the solution. So when we circle that, we also shade it to indicate that it is part of the solution. For x less than 4, it is represented like this. Now for these inequalities, the possible solutions are unlimited. Sometimes we could have an inequality in which the range of values of possible solutions is limited. This comes from combining two inequalities. Consider x greater than 1 and x is less or equal to 6. X is greater than 1 can also be written as 1 is less than x. Equally, x less or equal to 6 can be written as 6 is greater or equal to x. We are simply reading it backwards. These two inequalities can be combined into 1 less than x, which is less or equal to 6. This is called a compound inequality, and it can also be represented on a number line. Here's the number line. We circle 1 and 6. X is greater than 1, and so all values greater than 1. 1 is not included, and so we don't shade. But then the same x is less or equal to 6, and so all values from 6 and below. 6 is included, and so we shade. So the solution range is in this thick part of the number line. Next, solving linear inequalities. Linear inequalities are solved in just the same way linear equations are solved. We assume the inequality sign is an equal sign. However, when we divide or multiply the inequality with a negative number, we also reverse the sign. For example, 4x minus 3 less x plus 1. We subtract 2x on both sides. 4x minus 2x is less than 1 plus 3. And so 2x is less than 4 and x is less than 2. Again, 5x plus 3 is less or equal to 6x plus 9. We bring 6x to the left side of the equation and we have minus x is less or equal to 6. To remain with x, we divide both sides by minus 1. And so we shall have x, and now we reverse the inequality sign. We have greater or equal to minus 6. Lastly, I have x plus 5 is greater or equal to minus 1. We take 5 to the right hand side and we remain with I have x is greater or equal to minus 6. To remain with x, we multiply both sides by 2. And so we shall have x is greater or equal to minus 12. Notice that the sign does not change because we have multiplied by a positive number. The next part is graphical representation of linear inequalities. Just like the linear equations were represented using straight lines, linear inequalities can be drawn on a graph. We usually assume the inequality sign is an equal sign. However, the line drawn is dictated by the nature of the inequality sign. When we have greater or equal to or less or equal to, the line is continuous, and when we have greater than or less than, the line is broken. Consider an inequality y plus 2x is greater than 4. We can write this as an equation y plus 2x is equal to 4, but don't forget the sign. We then look for 2 points as usual. So first we rewrite the equation in the form of y is equal to mx plus c, and that will become y is equal to minus 2x plus 4. We choose any two values of x and calculate the corresponding values of y. We'll choose 0 and 1. When x is 0, y will be 4. And when x is 1, y will be 2. And so these are the 2 points, and we draw the line now. But wait, the inequality was a greater than, and so the line is a broken one. So that is the line. Now another thing is that the inequality sign represents a region below or above the line that satisfies the inequality. The side that does not satisfy the inequality is shaded off. To get the right region, we choose a test point. We substitute the point into the inequality, and if they reflect the truth, then that point is in the required region. So we shade off the other region. For example, in our case, is the required region below or above the line? To test that, we choose any point anywhere. For me, it is always safer to choose the test point 0, 0 because it makes it easy to calculate. 0, 0 is below our line. Is it the required region? Let us substitute 0 into the inequality. 0 plus 2 times 0 is greater than 4. 0 is greater than 4. Of course, that is not true. 0 is not greater than 4. So this side of the line is the unwanted region, and so we shade it off. And so the region that satisfies the inequality is on the other side, above the line. Now suppose we had chosen a point on that side on the required region. Let's see if it would satisfy the inequality. Let's take a point 4, 2. Substituting, we shall have 2 plus 2 times 4 is greater than 4, and we get 10 is greater than 4. Of course that is true. 10 is greater than 4. So that region satisfies the inequality, and it is the required region. And you can take any point above that line and it will always satisfy the inequality. Any point below will not. It is the unwanted region. Let's try another one. X plus y is greater or equal to 5. We write it as an equation. X plus y is equal to 5, but we don't forget the sign. And so in the form of y is equal to mx plus c, we shall have y is equal to minus x plus 5. We look for 2 points to help us draw the line. We get 2 values of x, and using the equation we calculate the corresponding values of y. We'll choose 0 and 1. When x is 0, y will be 5. When x is 1, y will be 4. These are the points, and we know the line should be continuous in this case. That is our line. The next thing is, which side do we shade? We take a test point. I always want to take 0, 0. It's the best point to use. We substitute. 0 plus 0 is greater or equal to 5. 0 is greater or equal to 5. Of course, this is not true. 0 is never greater or equal to 5. So this point is on the unwanted region, on the unwanted side of the line, and we shade the whole region. Lastly, y minus x is greater or equal to 1. First, we write it as an equation. Y minus x is equal to 1. We rewrite it in the form of y is equal to mx plus c, and we shall have y is equal to x plus 1. We look for 2 points, choose 2 values of x, and calculate the corresponding values of y, which is 0 and 2. When x is 0, y will be 1. When x is 2, y will be 3. These are the points, and the line again will be continuous. So we draw the line. Now we look for the side to shade, the unwanted region. We get a test point. We can choose another point. It's not necessarily that we have to choose 0, 0. In this case, let me take 2, 4. We substitute it in our inequality. 4 minus 2 is greater or equal to 1, and we get 2 is greater or equal to 1. This is true. 2 is greater or equal to 1, and so the point 2, 4 lies on the wanted region, and so we shade the other side below the line. We move on. Now we look at graphical solutions of simultaneous inequalities. Now, when we have more than one inequalities, it means that they represent a certain region which satisfies all the inequalities simultaneously. To get the required region, we draw all the lines on the same plane. Get the test points for each line and shade off as necessary. What will remain is an unshaded region between the lines, and that is the required region. Let's take an example. Represent graphically the region satisfying the following inequalities. First inequality, x is greater than 1. Second inequality, y is greater or equal to x minus 2. And third inequality, x plus 2y is less or equal to 6. We start with the first line. As an equation, this is x is equal to 1. On the graph, this is the line. Notice it is broken. Now, which side do we shade? This is rather direct. Even without getting a test point, x is greater than 1. And so all region less than 1 is unwanted. We shade it off. The next line, y is greater or equal to x minus 2, the first thing we notice is that the line will be continuous. As an equation, this will be y is equal to x minus 2. Now we look for 2 points. Choose 2 values of x and calculate the corresponding values of y. We'll choose 0 and 2. And so when x is 0, y will be minus 2. And when x is 2, y will be 0. That's the line. Where do we shade? Take a test point 0, 0. We substitute in y is greater or equal to x minus 2. We normally substitute in the inequality and not in the equation. And if we do that, 0 is greater or equal to 0 minus 2. 0 is greater or equal to minus 2. Of course, this is true. And so the point 0, 0 lies on the required side of the line. So we shade the other side. Last line, x plus 2y is less or equal to 6. First thing we notice is that the line will be continuous. As an equation, x plus 2y is equal to 6. Next, we look for 2 points. The first thing we do is choose 2 values of x and calculate the corresponding values of y. We'll choose 0 and 2. When x is 0, y will be 3. When x is 2, y will be 2 as well. That's the line. Now, where do we shade? We take the test point 0, 0. We substitute 0 plus 2 times 0 is less or equal to 6. 0 is less or equal to 6. This is true. And so the point 0, 0 lies on the wanted side of this line. We shade the upper side. This unshaded region is the required region. This region satisfies all the 3 inequalities simultaneously. One more example. Illustrate on a graph the region satisfying the following inequalities. First inequality, 3y is greater or equal to x. Second inequality, 2y plus x is less than 12. Third inequality, 3y plus 8x is greater or equal to 24. We proceed. We start with the first inequality, 3y is greater or equal to x. Clue number 1, the line will be continuous. As an equation, 3y is equal to x. We choose 2 values of x and calculate the corresponding values of y. 0 and 3. When x is 0, y will be 0 as well. When x is 3, y will be 1. And that is the line. Where do we shade? We cannot take point 0, 0 at the test point because it lies on the line and it won't give us much information. So let's take a point below the line like 4, 0. And again, you can even take a point above the line, actually anywhere on the graph. We substitute the values in the inequality. 3 times 0 is greater or equal to 4. Get 0 is greater or equal to 4. Of course, this is not true, and so that point lies on the unwanted side of the line. We shade it out. Next inequality, 2y plus x is less than 12. Clue number 1, it's a broken line. As an equation, 2y plus x is equal to 12. We choose 2 values of x and calculate the corresponding values of y. We choose 0 and 4. When x is 0, y will be 6. When x is 4, y will be 4 as well. That is the line. Where do we shade? Now we can take the test point 0, 0. Substitute it. 2 times 0 plus 0 is less than 12. 0 is less than 12. That is true. And so that point lies on the wanted side of the line. We shade the other side. We move to the last inequality. 3y plus 8x is greater or equal to 24. Clue number 1, it's a continuous line. As an equation, 3y plus 8x is equal to 24. Two values of x, 0 and 3, corresponding values of y. When x is 0, y will be 8. When x is 3, y will be 0. That is the line. Where do we shade? Test point, we can take 0, 0. When we substitute 3 times 0 plus 8 times 0 is greater or equal to 24. We get 0 is greater than 24. Of course, this is not true. And so that point lies on the unwanted side of the line, and we shade it. So we remain with this unshaded region, and it is our required region. This region will satisfy all the three inequalities simultaneously. Lastly, interpretation of regions. So far, we have been shading graphs to indicate the required region defined by the given inequalities. The reverse is also possible. We can define the required region already shown on the graph using inequalities, and so we only reverse the process. The first thing to do is to determine the equations of the lines. These lines are also called the boundary lines. That will give us the equations of the lines, but we need them in the form of inequalities. To do that, we choose a point in the required region and substitute it in the equation of each line to determine the inequality. Lastly, we check whether the boundary line is continuous or broken. Let's take an example. Find the inequality that defines the unshaded region in this graph. Now, the first thing we do in step 1, we look for the equation of the line. Just like we did with the equation of lines, we choose any 2 points on the line. Let's take minus 3, 0 and 0, 3. With these two, we calculate the gradient of the line. So we shall have gradient is equal to change in y over change in x. 3 minus 0 over 0 minus minus 3 will give us 3 over 3, which is equal to 1. Now we can find the equation of that line. We choose an arbitrary point x, y, and one of the points, say 0, 3. And so y minus 3 over x minus 0 is equal to 1. We equate to the gradient. Cross multiplication, y minus 3 is equal to x minus 0, and y is equal to x plus 3. Now the boundary line is continuous, and so it's included in the solution. So the inequality is either greater or equal to or less or equal to. We take a test point in the unshaded region. 0, 0 lies on that side. Substituting it, 0 is equal to 0 plus 3, and we end with 0 is equal to 3. Obviously, 0 is less than 3, and so the inequality is less than. But we add the or equal to because the line was continuous, and so we have y is less or equal to x plus 3.
if you want to go on and major in math or do honors in math or do a career in math, you really do need to be good at it. But I think too many people stop out too soon because they've had bad experiences. I think math teachers have a lot of responsibility for that. We haven't taught it so well. We haven't provided the resources that people need. And so I think if you need help, you need to get it, and you need to get it early. And you need to work at it.